from TechCornerTV, and thanks to the nice people from Owon who sent this product for review, I have here today for you a function generator from the XDG2000 line, more precisely the XDG2100 with a maximum output frequency of 100 MHz, 500 megasamples per second sampling rate, 2 channels and a 7-inch color display. But as usual, I'll show you everything about this device in detail later on. So first let's see the features and what's in the box. Let's get to it. As usual, let's start by seeing what came in the box. Inside the box came this smaller box with a few cables and a few items in here. Let's start with this one. It's a USB Type A to Type B cable to connect the function generator to the PC. It is delivered with 2 BNC cables. I will use these in the tests. And a C14 socket to European style one. I don't need this one. Also in the box came, let me show you, a CD with software. XDG2100, and we have the normal Owon test equipment line in here. Okay. Yeah, very good. I would like to test this. Yeah, it will be very cool if they allow me to test this. And this also. So the next thing is the technical features of the device. The model I have here, it's the 100 MHz. It has 500 megasamples per second. It has a vertical resolution of 14 bits, 2 channels. Yeah. The sine wave can go up from 1 microhertz to 100 megahertz, as I already told you. Square wave up to 30 megahertz, pulse wave up to 55 megahertz, and ramp up to 3 megahertz. Okay, nice. Let's see inside. We have a few more technical details, the modulation modes. And yeah, it seems to have nice features. Moving on, let's see the user manual. Normally Owon spend some time organizing this. They usually are very nice user manuals. As you can see, you have infographics, very well organized, with bold and the keys that you have to press, bold in the interesting areas, the titles, and something you have to take notice. Yeah, it seems to explain most of the functions. Of course, it should be all of the functions, I think. How to configure USB port, the LAN port, to communication with the PC. Yeah, it seems very nice. So let me just put this away. And the unit itself. Let's start by the back. In the back we have a connector for modulation, external modulation or triggering. And we have here a 10 megahertz channel counter also. We have the USB, the LAN port, and in here we have the C14 socket with the fuse to connect to the mains. Like an oscilloscope, we have a handle to carry it, and it is very sturdy, very nice. And also we have some fit in here that will go like this. Yeah, nice. I will put this off because of the light. Yeah, better. In the front we have 6 sine wave types with also arbitrary and harmonics. In here we have the menu selection keys, 2 direction keys, the selection knob, it's clickable. Also the keypad, as you can see, we control channel 1 here, channel 2. We have the copy, it will copy, I will show you in a moment the information from one channel to the other. And we have the counter functions, the utility store for editing, for storing the waveforms and configuration, for editing the waveforms, the preset, and the help button. Okay, let's start the device. Let me just connect it in here, and yeah, it seems okay. I will use one of the supplied cables. They seem quite robust. Let me just take this out, and we have 2 connectors, one for sync in channel 1 and channel 2, and the output, it will go here. So let me start by connecting this to the oscilloscope. Yep. Before starting, I will now take this off. Ooh. Okay, let's start the oscilloscope now. This is the normal startup screen in the Owon products. It has the product line. I don't know if it is customizable or not, but yeah, it's nice. It takes a few seconds to boot, something like 15. Okay, already channel 1 is detected. Let's see what we have here. Okay, so let me start by talking a bit about the oscilloscope. I already explained this area, the keyboard. So in the screen we have in here the channel on and off indicator, what kind of waveform is in use, and in this zone right now we don't have anything, but it will display the trigger mode. Also in here we have the ohms, the resistance that is set. It can be 15 ohms, or you can customize this resistance or also use high Z. The same goes for channel 2. We have, for example, for the sine wave, the frequency, the amplitude, and the offset. Okay. In here we have the selection for the waveform type. I will now start the output. As you can see, the oscilloscope already detected. Let me just take this off. We don't need cursors right now. The oscilloscope already detected the sine wave. It's with 2 MHz, about 1 volt PPP. Let me just change the amplitude. With this we can change the values, or you can go and with the direction keys move to the digit that you want to use. Okay. Also, you can insert directly here the value. For example, if I want a PPP 5 volts, I can choose the number 5 and also VPP 5 volts, and it will immediately let me just do auto set, adjust the amplitude. You can also change the offset and the phase, as normally you can on a function generator. To change the frequency and period, just press in here in the menu selection. It will change the functions. You have also the amplitude selection and the high and low level selection. We can say, for example, that the high level is 3.5 volts and the low level is 1.5 volts, and it will be 5 volts VPP anyway. Okay. We have also the offset selection and the high and low level offset selection also. And also the start phase. You can see here the waveform changing as you change the values. And yeah, the same will happen with, for example, the offset you see on the screen. I have right now the beep activated. When you reach a value that it's out of range, it will beep, just that. Okay, let's put the offset at 0. Yeah, one of the cool things of this oscilloscope is the fact it can go up to 100 megahertz. Let's change it. When you change the frequency to 100 megahertz, he automatically adjusts the amplitude, the VPP. The maximum is 2.5 volts. Let's just do a auto set here. And yeah, 100 megahertz signal. Right now I am with 500 millivolts per division and 1 nanosecond per division in horizontal divisions. So yeah, it seems to be a nice sine wave at 100 megahertz. This oscilloscope is 300 megahertz, so it will handle without any problem this kind of frequency. Yeah, that's it. We have also here the modulation. You can modulate the sine wave or the signal, any signal. In the modulation, you have also the normal modulation types. You can select, for example, amplitude modulation. One of the weird things is this selector doesn't seem to work for anything, but you can use it to select the option and then press OK. As you can see, the modulation changed. We can, for example, change the depth also. We need to go in here. Okay. We can change the shape. For example, we can choose a square wave for modulation or a ramp. Yeah, noise, sine wave again. In terms of modulation, that's it. We have also the sweep functions. Let me just decrease the time so we can change the frequency. What is going on here? Our auto is faster. We have the sweep. We have the time in seconds for the sweep, the start frequency and the stop frequency, as usual. We have the type of sweep, logarithmic, step 2, and linear. And also if you want to use the internal or external trigger. And the third mode is the burst. In bursts, you automatically adjust the frequency. I will do here a single. Okay, we have a period of one cycle. Let's change the cycles, the number of cycles. Right now it's infinite. As you can see, I have here the number of cycles that it can generate. Okay. And this will run for 4 cycles. Let me just press this again and auto. Let's put this in infinite. You should be able to. Okay. Here it is. Let's just end cycle. Okay, we see there a burst. Here it is. Okay, so he runs 4 cycles each second. Let me just here it is. And that's the bursts. And one cool thing about this is you have, let me just take the bursts off. For example, I have here a 50 megahertz sine wave with a 2.5 VPP. As you can see on channel 2, we have different configuration. Pressing this button, the interchange, it will copy. You will be able to copy from channel 2 to channel 1 or from channel 1 to channel 2. Do a frequencies sync using these ports. Amp sync also, align the phase, or I want to do this one. Okay, and as you can see, he copied all the information from channel 1 to channel 2, and it started automatically the channel without I saying anything, because yeah, it copied the state of the channel. Let me just try to okay, this is the one that is selected to operate the cursors. Yeah. And yeah, that's it. I cannot use the trigger because I don't have the external trigger connected. So right now this is the main functions. We have also a counter. Okay, we can configure the coupling, the sensitivity, the HFR if it's on or off, and the trigger level. Okay, the frequency and everything else. And we have the utility where it is the version of the firmware, the serial number, checksum, and the runtime that's working. In the display menu, we can set the brightness. Okay, let me just move this. We can change the brightness of the screen. We have also the screensaver time. I don't know how much time we can put there, but anyway, 30 minutes seems okay. And the separator, if you want to use coma or okay, this one has to be, we can, it will be neat also if we can change the options in there using this. We can use we can eliminate the separator, use a comma as decimal separator, or a space. Also, we have the date. As you can see, it's almost 2 in the morning. It's not afternoon, it's the morning. And you can configure the date also in here. So back in here, we can turn the sync of channel 1 and channel 2, and we can also change the resistance, the load resistance of the function generator. If you press in here, you have 2 options, IZ or well, the 50 ohms, but the 50 ohms, when the cursor is blinking, you can change to any I think up to 10 kilohertz. Let's see, one more, almost there. I think this can be up to 10 kilohertz. Let me just check that. Yep, 10 kilo ohms. Sorry, I told you it's kilohertz, but it's kilo ohms. So you also, it was faster if I did it here, but you can also input the values in here and choose what you want. Okay, so instead of rotating all of that, I can do it like this. Yeah, that's it. And we have also the configuration for PC or USB drive. The network settings, right now it's not configured. You can change the IP address, well, the normal stuff for a network. And the system only 2 language, Chinese, well, 3 language. You have English, Chinese, and this should be another Chinese or Japanese, I don't know, but I think it's 2 different Chinese characters. You can turn the beeper on and off. The reference clock can be internal or external, the clock output on and off. If you have the penny here, you can do update firmware, and that's it for the utility menu. You have also the counter I show you, the store menu, that you can see what it's in memory. I will show you how to save something in here, and also the arbitrary files that you save. We have the presets. We can do a reset, factory or user reset. We can set the power to the last state or user state or factory default. And also we have 15 or 16 in this case different presets that we can use in the system, and we can save configurations for these presets. Okay, so it's 16 presets, 15 including 0, so 16. Yeah, let me just do a reset. It will put in the default state. We have also a very useful help key. For example, if you want to know what this key does, you just need to press the key, and it will show you the sweep, the modulation, the utility, the knob, everything, even the buttons. So yeah, it's nice to have this. And okay, so we have the square wave, the ramp, the pulse, the noise, and also the arbitrary. Okay, in the arbitrary we can edit. Well, we have a lot of arbitrary functions. We have the common with all the options, medical treatment, for example, EEG. Let me just put here, and we have to turn the channel on and do auto. Oh. It seems to have some difficulty to capture this. Yeah, it's all over the place. Well, it's just an example. Let me see. So we have the standard, for example, ignition. Okay. We have also, let's see what else we have. The mat functions. Okay. For example, the Gauss. And it's 152 different functions. For example, let me see, engineering, quake. Let's see, what is a quake? Okay. it feels better. Like this is the quake, and so yeah, fun test. What is fun test? Let me see this one. It's a square wave or something like that. Okay, but it's very cool to use this. We have the last one, it's harmonics, but in the arbitrary we can go back to here and we can edit the sine wave or the signal. We can choose from basic templates, like for example a square, or yeah, a square, it's a good one to test. And we have edit points. Let me just go back. Let's choose 3 points. 3 points, okay. And we can do edit points. If, for example, for point 1, I will set the voltage at 5. Yeah, it's okay. Point 2, the voltage will be, I don't know, 2 volts. 2 volts. And the point 3, the voltage will be something like, yeah, -1. -1. Okay, so it's set. Let's see what kind of square wave of signal we have. Okay, we have our signal already defined, so let's store in the system. We have here arbitrary file. We can choose the second one, for example. The first one was already taken. Yeah, let's save this. It's saved. I think this one is also what we have done, here. And yeah, let's see how it appears in the oscilloscope. Let's go here and we do a callout. And there it is, our signal, arbitrary signal in the screen. Basically, it's a 3-level square wave. In here, this should be something like erase everything. Let's do this, and okay, and it should erase, I think. Yeah, it says secure, but it should say something like erase all waveform is stored internal memory. Seems to work. Okay, so for example, for this configuration, let me just put here 100 megahertz sine wave. We have to change this to sine wave. 100 megahertz. And we can store this configuration set file and save. And if you want to, let's change the configuration now to 50 megahertz and press store and set file, and in the second save also. So if we go now to store set file and go back to the one we have with 100 megahertz, we do callout, and yeah, he gets the configuration that we had before. Pretty cool, yeah. And yeah, that's it. It's a fine unit. Let's see how we can control this with the PC. So let me show you the software for waveform editing. It's a quite simple software. Let me start by showing the options you have. So you can create a new waveform. Open already one that you saved previously. So you have several options. You can also save the waveform as image. Let's create a new one. You can specify the number of points. I will choose 10,000 and the voltage 1000 millivolts. Okay, that's it. You have already the system set up. You have here in the resume and undo also rework options. You can change the grid color. Let me just start by activating the grid, the background color, and obviously the grid color, as I just told you. You can work with data line or data points. This is the communications. I will talk about this in a moment. You can draw the freehand line draw or point edit. We have Chinese and English language available and a small about page. In here, in this taskbar, we have also the icons for the functions that I mentioned before. It's a quick access. For example, you can activate and deactivate here the data line. We can change from line drawing to freehand. Okay. And yeah, that's it. So I have my unit connected directly by the LAN port. We have also USB, but not using it right now. Yeah, using LAN port. On port 3000, we can specify this on the configurations menu, as I showed you before. We have also here the command line. You can send commands to the device. The first one normally fails. I don't know why, but the second always works, and so on. It's working okay. So we can send SCPI commands to the device directly to program it. Also, you are able to, let me show you, to connect by telnet, and in the same way you can send ADN command. Oops. You can send commands. For example, if we want to system restart. Oops, no, it's not like this. It's system restart. As you see there, it's restarting. Yeah, it will take a while. Let's continue. So in here we have, as I previously mentioned, the connection details, the port settings, and the way this should work is using this icon. We will be able to read the wave that is on the device. It's not working with me. I managed to get this working once using USB, but I think the problem is on my computer. I have a lot of drivers and a lot of stuff from the devices I install and test, and I have to clean up everything to have and start using virtual machines to have a more clean environment. But as you can see, it doesn't update with the heart that is on or the sine wave, for that matter, that is on the function generator. As I told you, I managed to get this updated once with USB, but it's very unstable, and I truly believe this is a problem of my system, of my configuration. So to update the function generator, we have here the right wave. It will connect to the function generator. It will upload the waveform file. Yeah, it says file download footage, but it should be final upload, I don't know. And after that, you will have to use the recall channel 1 or recall channel 2 to activate that waveform that you just uploaded. You press here, and it should do the upload. As you can see in the image below, it is not working. Again, I think it is my problem. I will show you right now. You should be seeing on the screen footage that Owon sent me, how the process should be. As you can see, it's quite simple. Right now we are updating the device, and in the same way to fetch the waveform that is on the device. It's a very simple operation and it should work. As I told you before, I have some issues, and I believe it's my problem because I had that same problem with other brands. So yeah, I will give the doubts in this one. Yeah, but basically this is simple. It's just this functionality, and the software works pretty well. Well, if I have managed to update my system, it will be much better. But as I told you before, I'm solving this out with Owon to see what's going on here. But the device seems to operate quite good. As you can see, it has a new place in my workbench. And yeah, let's wrap this up. To wrap this up, I think this is a nice function generator with a ton of functions and ton of waveforms already in it. A very nice 7-inch screen. It always helps, and it will be a nice addition to the workbench, since I will have now a 100 MHz function generator to better test the oscilloscopes that comes to the workbench for review. And in that note, I will do a review of the workbench I already have, like the Rigol and the Handtech and the Owon, the Loto, using this device to see how they handled, and also with a fast edge signal generator that will allow me to test using the rise time. It will be recorded soon, so stay tight. So regarding the XDG2100, it costs about 500 euros on AliExpress, $600 more or less for the 30 MHz model, and for the 100 MHz that I have here, it's more about 850 euros. Well, something like $950, $1,000. It's a little bit more expensive than the normal equipment that I test here, but it's for a different target. It's for a more professional target. It's a much more robust device with a lot of function, independent channels with the same performance. So yeah, that's something to consider. So you may think that I'm a little biased in my analysis through Owon, but I truly believe they have great equipment for a very accessible price, and not always given the due credit that they have. Well, that's it. That is my opinion. It's subject to critique, but anyway, that's what I think. If you think that in any way this review was useful to you, don't forget, give a big thumbs up. Yeah, please do. And if you haven't already, please subscribe and hit that bell so you can be the first one to be notified every time I post a new video. That's it for today. Stay safe. I hope to see you in my next video. Cheers.